Hello and welcome to tutorial 196 part 2. In the first part of this tutorial we looked at method scope and we converted the exponential moving average to a method. In this tutorial we're going to be looking at converting the average function, which is a simple function, into a method as well. The first thing we're going to do is look at the function just to check out the algorithm. So you can see average is equal to the summation of price divided by length. So you might further right click summation and you'll see the way that this is done. We're just counting back from 0 to the length minus 1, finding the price, summing them together, and then going in the average function, that the value of that is divided by length to give the average. So just bear that calculation in mind. So what we're doing first of all is we're plotting 6 is the average close over 14 bars. What we need to do now is create a method to do the same thing. So let's go up to top of the program where I've got the methods. Now you might think that you can do that by creating a method such as this one. In other words, we're returning a double, we're going to call it simple average, we've got the inputs, price, length, we've got a variable which is the scope is the method. In other words, it's not study wide, and we're just going through value 1, 0 to length minus 1 and the sum plus the price and going back a number of bars. However, if we try and verify that, very quickly find that we cannot, because the method has got no knowledge of previous values of that price. It's putting in one value of price. It hasn't got the ability to go back and see what that price was over various other bars. So we can't do it like that. What we actually need to do in this sort of case, and this is a good example of why some things are better done as functions, talking easy language here, some things are better done as functions and some things may be better done as methods. Anyway, there is a way of doing this as a method. It's just a little bit more complicated. So what we do, we have same name, simp_av, returning a double, but instead of putting in the price, we're going to put in a vector containing the price information we need and the length. And then we're just going to do similarly to the function. We're just going to go value 1 is equal to 0 to the price vector count minus 1, in other words the length minus 1, and then we're just going to calculate the sum and return the value of the sum divided by len, which is the length of our moving average. The big question now is, how do we create a price vector in which we can store that data, and how do we make sure that we've got the appropriate prices stored in it? First of all, we need to go right to the top of the chart and put in the variables vars prices, null. And then if we go down a little bit further, we'll see that in the one statement we need to do a prices equals new vector. And then finally, at the very bottom of the program, we populate the vector with the last count of closing prices. So what we do in effect, at the end of each bar, the last tick of the bar status 1 equals 2, we're going to push dot, or rather prices dot push back the value of close. So that's adding that price to the end of the prices vector. But then what we do, because we know that length is 14, we say if prices.count is greater than 14. So we've now got 15 values stored in the vector, and we really only need the last 14, or we only want the last 14. So what we then do is we say prices.arrays and then round brackets 0. So if prices contain more than the count item, then we're going to delete the value in the 0 position. Then we can do the calculation using the method. I just put in an additional thing here which just helps us to just make sure that the prices we do have stored in our vector are the ones that we want to use in our program, just to verify it. And then we call the method as follows. So we're saying value 7 equals simp_av, put in the two inputs, prices, which is the vector that we've created and updated, the length 14, and then plot 7, value 7. And if we apply that to a chart, and just make sure that the study is applied after the error that we had. Okay, we just need to verify that again. Okay, it's applied to the chart now, and you'll see that we're getting identical values for the plot, which is using the function, and the plot, which is using the vector. I say identical, just look, going right back to the beginning of the chart, there is a very short period where the value is converging to become the same value as the plot using the function. But apart from that, the value is exactly the same. However, as I said, this is perhaps an example where you would use the function in preference to the method. Anyway, hopefully that might be useful. If you're interested in this sort of thing, please go to markplex.com to join the email list, and also please subscribe to this channel wherever you're watching this video. Thank you very much.